What is the value of the sum of cosine theta to the power of 8 and sine theta to the power of 8 if a trigonometric equation is given? By trigonometric identity, cosine 2 times theta equals 1 minus 2 times the square of sine theta. Substitute in the given equation, and we have that 1 minus 2 sine square theta equals 1 divided by 3. Simplify by combining like terms, and we have that 1 minus 1 divided by 3 equals 2 times sine square theta. It implies that 2 times the square of sine theta equals 2 divided by 3. Divide the equation by 2 and we have that the square of sine theta equals 1 divided by 3. Take the square root of the equation and we have that sine theta equal the square root of 1 divided by 3. We take the positive value of sine theta. Since theta is an acute angle, by trigonometric identity, cosine theta equals the square root of 1 minus the square of sine theta. Substitute value of sine theta. Cosine theta equals the square root of 2 divided by 3. After substitution and simplification of values, now, substitute the values obtained in the given expression. This implies that the sum of cosine theta to power of 8 and sine theta to power of 8 equals the sum of 16 divided by 81 and 1 divided by 81, which equals to 17 divided by 81, after substitution and simplification of values.
Required to find the value of cosine x divided by 3. Let y equals x divided by 12 and the sum of sine y and cosine y equals 2 divided by 3, which we call equation 1. By trigonometric identity as shown for sine alpha, which we substituted into equation 1 to have that the sum of the square root of 1 minus cosine square y and cosine y equals 2 divided by 3. Thus, expand brackets to have that 1 minus the square of cosine y equals 4 divided by 9 minus the product of 4 and cosine y all divided by 3 plus the square of cosine y. Rearrange the terms as shown on the screen to obtain equation in cosine y. Multiply the equation by 9 to clear fraction. It implies that the product of 18 and the square of cosine y minus 12 times cosine y minus 5 equals 0. Assign cosine y to be equals to r. It implies that the product of 18 and the square of r minus 12 times r minus 5 equals 0. Use general quadratic equation formula to solve for r. It implies that r equals 12 plus or minus the square root of the sum of 12 squared and the product of 4, 18 and 5 all divided by 36. Simplify to have that r equals 6 plus or minus the product of 3 and the square root of 14 all divided by 18. Then, simplify further and we have thus, r is not equals to 2 minus the square root of 14 all divided by 6. Therefore, r equals the sum of 2 and the square root of 14 all divided by 6 in units. But r equals cosine y. It implies that cosine y equals the sum of 2 and the square root of 14 all divided by 6. We call this equation h. Recall that r equals to cosine y. It signifies that y equals the cosine inverse of the sum of 2 and the square root of 14 all divided by 6. This implies that by multiplying y by 4, we obtained x divided by 3. Thus, cosine x divided by 3 equals cosine of the product of 4 and the cosine inverse of the sum of 2 and the square root of 14 all divided by 6, which equals to 0.3827. Therefore, cosine x divided by 3 equals to 0.3827. Required to find the value of tan angle of the sum of x and y from the trigonometric equations. Let the sum of tan x and tan y equals 25 be equation 1 and the sum of cot x and cot y equals 30 be equation 2. It implies that the sum of cot x and cot y equals the sum of 1 over tan x and 1 over tan y, which equals 30. We call it equation 2I. Simplify equation 2I and we have that the sum of tan y and tan x all divided by the product of tan x and tan y equals 30 to be equation 3. Divide equation 1 by equation 3 as shown on the screen to obtain, after simplification, that the product of tan x and tan y equals 25 divided by 30. We call this equation K. Multiply equation k by -1. We have that the product of the negative tan x and tan y equals -25 divided by 30. Add 1 to the equation above. It implies that 1 minus the product of tan x and tan y equals 1 minus 25 divided by 30. Simplify and we have that 1 minus the product of tan x and tan y equals 1 over 6. This we call equation 4. Divide equation 1 by equation 4. It implies that the sum of tan x and tan y all divided by 1 minus the product of tan x and tan y equals to 150. But, by trigonometric identity, tan angle of the sum of x and y equals the sum of tan x and tan y all divided by 1 minus the product of tan x and tan y. Therefore, tan angle of sum of the x and y equals 150.
What the sum of the cosine x to the power of 8 and the sine x to the power of 8. Take the tan inverse of the given equation and we have that 2 times x equals the tan inverse 1 divided by the square root of 3. It implies that 2 times x equals to 30 degrees. Divide the equation by 2. X equals half of 30 degrees, which equals to 15 degrees. Substitute in the given expression and we have that the sum of cosine x to the power of 8 and the sine x to the power of 8 equals the sum of cosine 15 degrees to the power of 8 and the sine 15 degrees to the power of 8. Simplify the results in radical form and we obtained 97 divided by 128 after substitution of values and simplification. Therefore, the sum of the power of 8 of cosine x and the power of 8 of sine x equals to 97 divided by 128.
What is the value of the sum of reciprocal of sine beta to power of 6 and reciprocal of cosine to power of 6? By trigonometric identity, cosine beta equals 1 minus the square of sine beta. Substitute in the given equation, and we have that the sum of sine beta to power of 6 and the cube of 1 minus the square of sine beta equals 1 divided by 4. Expand bracket, combine like terms and simplify. This implies that the product of the square of cosine beta and the square of cosine beta minus the square of sine beta plus sine beta to the power of 4 equals 1 divided by 4. Substitute trigonometric identity for the square of cosine beta as shown on the screen into the equation above. And we have a new equation in terms of sine beta. Let the square of sine beta be equals to u. It signify that the product of 1 minus u and 1 minus 2 times u plus the square of u equals to 1 divided by 4. Expand and combine like terms. Simplify, and we have that 3 times square of u minus 3 times u plus 3 divided by 4 equals 0. Multiply by 4 to clear fraction. It means that 12 times the square of u minus 12 times u plus 3 equals 0. Divided the equation by 3, and we have that 4 times the square of u minus 4 times u plus 1 equals 0. Factorize. This implies that the square of 2 times u minus 1 equals 0. Take the square root of the equation. 2 times u minus 1 equals 0. Simplify. It follows that u equals half, but u equals the square of sine beta. This implies that the square of sine beta equals half. Find the cube of the equation. Hence, the cube of the square of sine beta equals the cube of half, which equals 1 divided by 8. We call it equation 1. It implies that, by using trigonometric identity, the square of cosine beta equals 1 minus the square of sine beta, which equals to half. After substitution and simplification of value, take the cube of the equation, and we have that the cube of the square of sine beta equals the cube of half, which equals 1 divided by 8. We call it equation 2. Substitute equation 1 and equation 2 into the given expression, and we have that the sum of The reciprocal of sine beta to power of 6 and the reciprocal of cosine beta to power of 6 equals the sum of reciprocal of 1 divided by 8 and the reciprocal of 1 divided by 8, which equal the sum of 8 and 8. That is, the required result equals to 16.